He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
This is an episode about AI. So, here's where I could play a clip of my voice as recreated by AI. Or a song that AI made up based on prompts I gave it. But I'm not going to. I don't want to give AI any leg up on what I do. It may well one day come for my job. But it's also an amazing multi-purpose tool that can help us in lots of ways. Kia ora, nau mai haramai ki te ao hurihanga. Hello and welcome to Our Changing World, ko Concannon tēnei. When I say AI, what do you think of? AI summaries in search engines? Generated photos where the fingers don't look quite right? Weird videos shared online? Or using ChatGPT to write a last-minute wedding speech?
Because ChatGPT sort of came along and turned the world upside down, everyone associates that with AI without understanding sort of the wider spectrum of techniques.
This is Dr Andrew Lensen, Senior Lecturer in AI and Programme Director of AI at Victoria University of Wellington. Conversations
like this are really good because we can be like, here's other ways we can use it that are beneficial to society and that aren't based on big tech companies.
The potential of AI is vast, and most of us are experiencing just a little sliver of it in our daily lives. So today, we meet three people putting AI to use in the realms of conservation, primary industry, and public health. First though, what do we mean when we say AI?
Often when we talk about AI or machine learning, we're talking about things like deep neural networks. So people might have heard of deep learning before, and that's sort of these modern methods that are really, really big models, so lots of numbers in them, like billions of numbers, and they're really high performing because they're so complex and so sophisticated. But of course, it's very hard for you or me or even an expert in deep learning to look at those numbers and figure out what it's doing and how it's going from, say, being given a photo of an animal to saying that's a bird or that's a cat.
So data goes in, answer comes out. But the process in between is a mystery. Andrew's research focuses on something called explainable AI.
Explainable AI, I guess, sort of takes a different approach where we go, well, okay, what if we make a model that's sort of even less complex and maybe not quite as high performing, but then we can understand it a lot better? Or sometimes we even try and take these really complex models and say, okay, after we've made them, can we use some sort of special techniques to try and pick out maybe some patterns in there, sort of trying to explain it post hoc. So it's a bit of an art form as well as a science, but I guess there's this trade-off, right, between models that are really, really high performing and ones that we can sort of trust, and it's where you sort of go on that spectrum.
Yeah, that's interesting where you say ones that you can trust,
yes.
And that's because you can look under the bonnet and you can see all the bits, and then presumably once you understand how it's working, it's easier for you to tweak each little step as you go along to make the model do what you want.
Yeah, so there's sort of a scientific benefit there too, right? Especially again in applied research, you can validate, is what a model doing in line with what the ecologist knows or the health professional knows? Does this make sense to them? Does it resonate with their very advanced domain knowledge? And that both allows you to, as you say, refine and validate it, but also for the practitioner to go, oh, okay, I'm actually going to trust this model and I'm going to use it as part of my job or part of my workflow. Because the worst thing you can do as a computer scientist is go along and say, hey, I've made you this cool thing, just trust it, it's fine.
We're at the stage now where there's a range of options if you want to use AI to tackle something. If it's a common problem, you could just buy something off the shelf. For example, in the RNZ podcast team, we use an AI transcription program that converts audio to text. An RNZ social media team recently started using an AI tool to moderate comments. And more New Zealand businesses are doing this all the time. But if your problem is too bespoke and nothing on the shelf exists, there are two options.
So there's this idea in deep learning where we have what are called pre-trained models, which are these deep neural network models, so things like large language models, but also for vision tasks and audio tasks and other things, that have been trained on a whole bunch of data. And that might be, very diverse data. So for example, in image classification, where we want to say, is this a photo of a bird or a rose or a RNZ building? That model would have been trained on maybe millions or more images that have different labels saying this is a building, this is a bird, this is a duck. And so as a researcher, I can take one of these models and then I can do what's called fine-tuning, which is basically train it a little bit more for my specific problem. So I might, be really interested in kākā versus ducks or something. And so I give it more images of kākā and ducks and say, I want you to distinguish these really well. And so you take all that sort of existing training where it knows these sort of quite general things about what buildings look like and what birds look like and these sort of what we call these features in images, and then you fine tune it and you get a good result without having to have like a million photos of ducks to start with. And that's one of the deep learning approaches. You can also try and make your own one from scratch, but especially with deep learning, you need a lot of data to do that, and often, especially when you talk about applied research, data is scarce. But we also have a whole field of, I guess, more traditional or slightly older techniques, so things like more fundamental machine learning techniques, sort of tree-based approaches, or things like clustering, and things that were around sort of before deep learning and are less complex, but often can be more than sufficient for certain tasks if you sort of design your data sets well and your problem well, and also tend to work better with less data.
Professor Bing Xue, also of Victoria University of Wellington, has worked on a number of different applications of AI, including healthcare, climate change, and energy systems. And she uses both options.
It's a mixture of using existing tools as well as developing brand new tools from scratch.
Bing is currently part of a 7-year, $13 million data science program aimed at developing tools for aquaculture, specifically green-lipped mussels, king salmon, and oyster farms.
It's trying to using AI technology to automatically monitoring or help the decision making. For example, we're looking at basically the entire life cycle of our green mussels, from tracking the initial settlement of spat to assessing, their growth and monitoring all the mussel farm, to predict the harvest of the mussels.
This includes a system that will let the farmer know when something needs to be done.
We call it maybe an alerting system. Say we capturing the camera can be on the farm, on the buoy, and then all the data captured, then our machine, our AI tools can process it on the farm, and basically at the end sending alerting system say you need to add in more buoys, or all the buoys there may be something wrong with it, you need to take action on it. For king salmon, it could be you need to clean the net. There are too much of biofilms. And also the salinity level for oyster farm, you say it's too low or it's too high, now you need to take some actions.
And there's quite a big team working on this project across a number of organizations.
I have been working with my colleagues, with AI experts, and we work a lot with marine biologists and the farmers from Nelson and from Marble Sound in Nelson. We work with croissant and plant food. We also working with the technicians, engineers in developing the mussel farm facilities.
At this applied end of AI, Bing, who's an AI expert, has to understand how an aquaculture farm works in order to develop something that will help. She did a lot of reading about it beforehand, but she's also visited the farm several times.
I learned things that I would never know when I'm working only AI in lab. You see, there's so much achievement in AI globally, but I'm quite sure if we want to solve a real-world problem, we would really have to work with the experts in that particular area.
Currently, they're building the tools. There are different requirements. Some are image-based, others look at numbers. The next stage will be to test them in the farms.
The ultimate goal is to developing, more cheap, automated, and sustainable tools and to the farmers to boost the productivity.
For Dr. Fiona Callaghan, it's not about productivity, but preparation. Fiona is the Chief Advisor of Epidemiology for the Ministry of Health's Public Health Agency.
New Zealand is at high risk for a measles outbreak or a measles epidemic, partly because it's been a while since we had the previous measles outbreak, and these things tend to come in waves, but also because our vaccination rates are not where they need to be to prevent outbreaks. So we decided to work with PHF Science to create a model to try and run up some scenarios as to how an epidemic might play out in 2024 or 2025.
PHF Science, Public Health and Forensic Science, is a government research agency, previously ESR. before the recent science sector reform. They've got a lot of scientific expertise in infectious diseases, but they also have something very helpful for this kind of modelling: ALMA. ALMA stands for Aotearoa's Large-Scale Multi-Agent Simulator, basically a digital replica, or sim, of New Zealand. They can use this digital twin of the country with AI predictive modelling to ask all kinds of what-if questions.
It's very useful for infectious disease and public health because they're able to take what they call a synthetic population of New Zealand. So this isn't the real data of New Zealanders, but it's a kind of a simulated model of New Zealand. And then you can say, well, what would happen if we had one infectious person from overseas maybe attending a school, or what would happen if there was an outbreak starting at the airport? And you can be very sort of specific like that, and then follow the trajectory of how something like measles might spread in the population.
They didn't run it on a national scale. Instead, they did 4 regional models to see how a measles epidemic would play out in each of those: Northern Region, Central, Lower North Island and South Island. And they run the simulation many times to see the range of how bad an outbreak might be, to help them prepare for the worst. The first thing they did, to check whether it was modelling things correctly, was to recreate the measles outbreak that New Zealand experienced in 2019.
That seemed to match with what we actually saw in real life. Then we started asking questions: what would happen if we were able to do an uplift in vaccination rates of 5% or 10%, and what kind of impact that would have on the size of the outbreak. And once an epidemic or an outbreak started, what was the effectiveness of uplifting that vaccination rate as the outbreak is occurring? Is that something that is worth doing? Obviously, it's better to have vaccination coverage higher prior to an outbreak, but it is still valuable to have that boost and that uplift within the first month or so of the epidemic. So there are still things we can do once the epidemic gets going.
The model is quite detailed, so they could also query what would happen if they focused on specific populations.
Targeting Māori and Pacific populations within, say, the Auckland region has a significant impact on reducing the total number of cases, as does vaccinating earlier rather than later in the course of an outbreak. And so those things were interesting to know. I think we knew those before the modelling started, but we were able to put a sort of a quantification on top of that. And it was very useful to know measles spread so quickly. It was very valuable to know that it is still useful to vaccinate even as the outbreak is beginning to grow.
Measles was the first cab off the rank for this AI modelling. But Fiona expects they'll use it in the future for other infectious diseases. It's not a prediction, and it has limitations, but it does help them understand the spread and what interventions might work.
This kind of model that really looks at how New Zealanders behave and takes in all sorts of data systems to look at who's going to school every day, what the family size is, how often are they going into work, or are they working from home. It takes all of these kind of factors into consideration. Works really well for an infectious disease model where like the main thing you really want to know is how often are people interacting and how big is the household size. So yeah, I think this model could really be useful for a lot of different infectious diseases.
In terms of the wider use of AI in the Public Health Agency, Fiona says it's early days for that. They're currently working on principles and guidelines. Back to Dr Andrew Lensen, who's also currently working on a few applied AI projects. One involves optimising a type of targeted chemotherapy, but the other is aimed at helping some of Wellington's feathered inhabitants.
Ever since Zealandia opened in the early 2000s in Wellington, and they made it sort of this predator-free eco-sanctuary, they then reintroduced, I think, about 14 or 17 kākā in the early 2000s into Zealandia, and since then the population has exploded.
Wellington residents are getting used to kākā chatter as this native parrot returns to the city. But it's not all sunshine and rainbows.
Kākā like to start nesting in attics or pulling people's gutters apart or tearing down your favourite rose, as well as things like accidental poisoning from lead or from sort of bait stations. And so this is all sort of, I guess, a bit of context to say that we don't really understand how widespread these problems are. And normally ecologists would go along and tag the birds, so put little metal rings around their feet, but there's some issues with this, right? So firstly, kākā are quite bitey. They also like to roost and nest up trees, which are quite hard to get to. And we're fortunate now that there are so many kākā that it's not really possible to ban them all anyways.
This came up in a conversation with his colleague Dr Rachel Shaw, senior lecturer in behavioural ecology, who said, "I wish we could just identify each kākā on site." To which Andrew said,
"I'm sure we can figure it out."
And so began a multidisciplinary project to learn about the return and urbanisation of this manu.
We're sort of combining ecology, AI and also Mātauranga Māori to try and understand how this bird lives in Wellington and whether or not we can recognise, Bob or Jill or Jeff or whatever your kākā names are as they travel across the city and across different years.
Now, asking AI to tell a kākā from a duck is one thing. But how do you train it to tell individual kākā apart?
I guess the motivation is that we are quite good at recognising humans, and we have lots of computer vision techniques that do really good facial recognition of humans. Like some countries in the world, they have systems where you can be recognised among 1 billion people, right? And so the technology clearly can distinguish human features. And when we look at, when my ecology colleagues look at kākā, they can also tell them apart based on things like their beak patterns, the curvature of their beak, maybe their posture, any scratches on their beaks, that sort of thing. And so we started off by doing a pilot study at Zealandia probably 2 or 3 years ago, where we put up a feeder box in Zealandia, put nectar in it that they really like, put a GoPro inside the box, and the kākā would come along, stick its head into the box, have a drink and get its photo taken.
They also had some students who recorded the few banded birds that visited the cameras. So they had a small amount of labelled data. But most of it was just kākā headshots. So they used a type of machine learning called unsupervised learning,
which is all about trying to separate different pieces of data when you don't know those labels. And that looks at sort of those features I mentioned earlier, right? So we can capture whether the texture or the gradient in the beak, how long the beak is, even the position the bird feeds at. And we found that by doing that, we could then, with sort of 80-90% accuracy, usually match a given image that we're taken to the next sort of closest image, and it would be the same bird most of the time, about 80 or 90% of the time. Of course, this is quite early research, like feeder boxes in Zealandia with a nice white background, is a starting point, but what we're doing with this funded research is scaling it up. So we're getting more cameras out there, we're moving beyond feeder boxes to sort of more realistic backgrounds with trees and things. And eventually we hope we'll be able to look at things like citizen science. So if you take a photo of a kākā and you can upload it somewhere, maybe we can be like, oh yeah, that's the same guy you saw 3 days ago in your backyard. And then it's also a really cool way for people to connect with the bird, and especially Māori to reconnect with the bird and sort of help maybe rediscover some of that Mātauranga and connection as well.
From the ecologist's point of view, it will help them get some data around which birds are in different parts of the city, where they commute to each day, and which birds are hanging out in a group together. And there might be other species it could be extended to.
Something we could look at would be kea or other native parrots. One of the reasons we started with kākā because parrots have reasonably distinctive features. Like I wouldn't really want to try and do it on a tui or something, or other songbirds. It would be harder. You'd probably do audio recognition or something there. And so we're quite interested in how we could extend it to other parrots in New Zealand, other parrots internationally. And so part of our research is also over time making this sort of open source and making it a tool that other people can learn from, as well as a model for perhaps how to do this sort of form of applied AI research.
Now, alongside his apply AI work, Andrew also researches some of the social and ethical implications of AI in New Zealand.
I sort of spend quite a lot of time thinking and often at 2 a.m. sometimes, about some of these issues, right, like bias in decision making, things like deep fakes, or even just how we can position New Zealand. People often say we're small, it's very hard for us to have impact, right? But at the same time, I think we are quite well positioned to lead in doing things the right way. So when I say things like trustworthy AI, I think New Zealand as a nation, we've often led in things like the Christchurch Call or nuclear-free movements. We've often gone beyond our size. And so I'm quite interested in how we can maybe position ourselves both in a regulation sense, but also almost in the market as someone who is doing AI in a more trustworthy way.
The idea of deep fakes, of creating, say, voice replicas that sound exactly like someone, that you could use to trick someone else, that really freaks me out. But Andrew also talked about other impacts that large generative AI models designed in the US are likely having on us.
We actually see things like more American culture coming through to New Zealand from the use of things like ChatGPT. Sometimes it's a little bit subtle. And so there's also questions around how this is sort of affecting our society in terms of what New Zealand is, because we've been exposed to these models, right, often at times without really consenting to it. And I think also we see when people use social media, right, you see a lot more misinformation and disinformation from generative AI, and it's getting much more subtle as well. So there's sort of those slightly more subtle issues that are playing out over time, and it's harder to sort of pin those down and sort of research those. But all that sort of stuff, I think, is something we need to be having better conversations about and being more aware of, because a lot of people don't always know what we mean by AI. They think of ChatGPT, and that is part of it, but there is also things like recommender systems, like Facebook's feed, where they say, this is what you're going to look at today. And that has a massive influence on our society, what we think, how we talk to people, political polarisation, right? Like there's a whole bunch of these issues that are not necessarily new, but AI is sort of making them worse at scale.
These concerns are part of the reason why Andrew was not impressed with the government's AI strategy, which, when released in July this year, was described by Science, Innovation and Tech Minister Dr Shane Reti as a light-touch approach to encourage uptake by industry.
I was fairly ruthless in my critique of it, I think. Academics like myself were upset because there was very little mention of the ethical issues of issues like Māori data sovereignty. There were some really good guidelines, but the strategy itself had no teeth, right? It's like, here is some ways you could do things correctly, but we're not going to make you. And I mean, that's just, not good enough in 2025.
Because of this, Andrew and a number of other AI experts published an open letter in September that they addressed to the leaders of all political parties, asking them to introduce AI regulations.
We need to move quicker on this, and we need to do it in a bipartisan way, because we don't want to have a situation where we have a government like the current one who releases a strategy, and then maybe we get a new government and they do something quite different, because that then also introduces uncertainty, not just for individuals in society and their rights, but also for businesses. And yeah, we're really keen to get involved in this and to talk to politicians and try and really push this forward, because we see it as obviously a big issue. And if we do it right, it could be something that is quite beneficial for New Zealand as well. It's not all about the harms, right? There's lots of potentially good uses there too.
In place of bespoke regulation, the government's current AI strategy outlines that AI use will fall under existing policies around privacy, competition, consumer protection, and human rights, and that these regulations can be updated as needed to make sure they're fit for purpose. A recent example is the Biometric Processing Privacy Code, which was announced in July and outlined new rules for the use of biometric technology, things like facial, voice, or gait recognition or fingerprinting. Here's Privacy Commissioner Michael Webster speaking on RNZ.
While there's not a lot of use of biometric technologies at the moment in New Zealand, its use is increasing. And because of that, and because of its sensitivity, it is the most sensitive personal information, we thought it was timely to create some stronger and clearer rules about the use of biometric technology.
But Andrew Lensen would like to see specific AI regulation, similar to the risk-based pyramid structure that's part of the European Union's AI Act.
There's a lot of low-risk AI uses at the bottom of your pyramid, things like using ChatGPT to summarise your emails, things like that, which we probably don't really need to regulate or have oversight of. That's up to you. You can make the best judgment there. And at the top of the pyramid, the pointy bit, there's some really high-risk stuff like social scoring or state surveillance. Those are the things that Kiwis just don't want. And so we would need to sort of ban those and say, no, you can't do that. And then in the sort of middle of the pyramid is those slightly more nuanced ones. So when you think about things like automated decision-making, whether or not you get a bank loan, right? Potentially there's some good uses of AI there because you could get a decision more quickly, but we would also want to make sure that it's not looking at things like your ethnicity or your criminal record, or sort of those quite sensitive and protected attributes. And so we're sort of proposing that New Zealand could also take that risk management, risk-based approach where we go, here's the stuff we don't worry about, here's the stuff we're not going to allow at all, and here's sort of the interesting stuff in the middle where we need to have slightly more subtle rules and probably some sort of oversight as well.
Interestingly, this is a similar approach to what the government is proposing for regulating the use of gene technology in New Zealand. For Andrew, AI literacy for all, plus talking about these risks and what we are and are not okay with, are really important for our future with AI.
At the moment, it's basically being used on us a lot, especially on the internet, right? We don't have much say on that. And so if we have these conversations about regulation and have these conversations about how it's used and what is okay in our culture, then put the mechanisms in place so that we can use it appropriately and maximise those benefits and minimise those harms. We're always going to see harms from it because there's always going to be people who don't use it appropriately. But if we can at least do the best we can, I think that will help the public sentiment, because New Zealanders are also really not trusting of AI. I think 66% of Kiwis are sort of scared or don't trust it. And so we also need that leadership. If I want this AI healthcare treatment to be used and then the patients go, I don't like AI, then that's sort of a lose-lose, because they don't get very good treatment and also we're not able to improve health outcomes.
Thanks to Dr Andrew Lensen and Professor Bing Xue of Te Heranawaka, Victoria University of Wellington. Thanks also to Dr Fiona Callaghan at the Ministry of Health. This episode was produced by me, Claire Concannon, and sound engineering was by William Saunders and Jeremy Veal. If you have feedback or questions or want to share your fears and dreams for our AI future, you can email ourchangingworld@rnz.co.nz. Tēnā koe I whakarongo mai. Thanks so much for listening. Have a great week. Kia pai, the wiki.